today, Common Core, GCO12, and it's proving theorems about similar triangles. And the three that we have, we've got our angle, sim, we've got our side, side similarity, and we've got our side, angle, side similarity. Those are the three that we're going to use to prove two triangles are similar, okay? So first of all, example 1. What would be helpful for me is for me to redraw it so I've got them set up. So I'm going to take triangle PRQ and I'm going to draw it right next to it, okay? So let me redraw PQR. Because if I draw it with the same orientation, it helps, okay? So I got the 6 here and the 6 here. I'll put the 9 here. And then this is going to be my R, and my P is up here, and my W. You don't have to do this, but I have found over the years of teaching that for a lot of kids it's easier if I do this so you can see it if I just go ahead and draw them out in proportion. Okay, so then you see the two triangles. So how can I prove them? Well, I don't know anything about the angles, do I? But I can probably set up the sides. So if all three sides have the same ratio, boom, we did it. So what do I mean by setting up all three sides? Well, let's go. The 4 goes to 6. You guys agree? This side goes to this side, so we'd say the 4 goes to the 6. As this 4 goes to this 6, right? As this 6 goes to this 9. Now if I reduce those, and you know, if you don't know how to reduce very well, the calculators will do it. In fact, I'll show you again how the calculators will do the work for you. But I'm hoping you guys can reduce these fractions. I really am. I'm really hoping you can reduce these fractions. But if you don't know how to reduce fractions, the calculator will do it. If you go 4 divided by 6, go to your math button. There's your fraction button. 2/3. Now hopefully you guys can do that. 2/3, 2/3, and the same thing, divide both by 3 and you get 2/3. So are they similar? Yes. Yes. So we're going to say yes. We're going to say triangle. You ready? PQR, triangle PQR. So is similar. So my little similar side, because they're not congruent. They're not the same size. They're similar. So PQR is similar to triangle PRW, right? PRW by side, side, side similarity. Okay? There it is. 1 thumb up, 2 thumbs up. Okay? Nice. Okay? All right? Let's take a look at number 2. So number 2, it doesn't really look like I've got two triangles, but I really do. I've got the big triangle and the little triangle. So let me go ahead and outline both. Okay, here's the big triangle, okay? And then you see the little triangle inside, okay? So let me go ahead and just keep the little triangle where it's at. I'm going to do this on purpose. So let me keep the little triangle where it's at. Here's my little triangle. And then I'm going to redraw the big one over here on the side. And the reason I want to draw the big one on the side is because its length is 6. Its length is 9, okay? So if I redraw the big triangle on the side, you'll see that the side is really 6 and the side length is really 9, okay? Now, let's set up my ratios. So I'm using the little triangle with the big triangle, okay? So 2 goes to 6, right? As 3 goes to 9. Are those two congruent fractions? 1 out of, yeah, I can reduce that to 1/3 and to 1/3. Now, what else do I have? Claire, go ahead.
The top angle is the same on both of them because they're like on top of each other.
Right, by the reflexive property, right? We know angle J is congruent to angle J, right? So then they have the angle. So in this case, we have the side, angle side, and we have the side, angle side. And not that the sides are equal, because they're not, but they have the same ratio. So we can say yes. We can say that triangle MJN, triangle MJN is similar to triangle KJL. KJL by side, angle, side, sim. You got to put the sim because the sim stands for similarity, okay? That's not too bad, is it? Not too bad? Okay, let's look at number 3. Okay, now number 3, if I take a look at 3, I see there's a couple of ways to do this. It really is. So to verify the two triangles are congruent, I can't really use my, I don't know anything over here. I mean, it almost seems like, hey, I can do the side thing, but I can't do it. But there's one other thing. I know for sure. What do I know? Actually, I don't want to tell you. What do you know? Do you see anything? Claire, what do you see?
Alternate interior angle.
There you go. You're way ahead of me. I like that. That angle's got to be congruent to that. So you guys agree that angle C has got to be congruent to angle E, okay? Great. What else do you see?
54 and 54.
54 and 54, but it's to other sides. Yeah, Claire, what else do you see?
That the vertical angles are equal.
Right. You guys agree with vertical angles? We could also use the other alternate interior angles also. But let's go with what Claire said. Let's say this angle is congruent to this angle. So I also know that angle CBA is congruent to angle EBD by my vertical angles. So at this point, remember we only need two things. We only need two angles, right? We've got it. So we can say that triangle, we'll say CBA is similar to triangle EBD by angle sim, okay? And we actually could have said the other angle too. That A is equal to D by the same thing, by the alternate interior angle. So that's, I'll put AI there, alternate interior angles. I'll put VAT there for vertical angles, okay?
You put C at the end instead of B.
Katie, why do I do that? I need more sleep these days, huh? Okay, easy. All right, example 3. It says, in example 3, find the value of BE. Well, I can do that. I can do that because I'm going to look at two different triangles here, okay? I'm going to look at the big triangle. Let me highlight the big triangle, okay? Everybody looking at the big triangle? How long is this side? How long is EA? Everybody, how long is EA?
X plus 3.
Good. You need to know that. Everybody see that EA, this length here is X plus 3. Do you guys agree with that? So let's set it up. And then there are so many. In fact, Megan, you were asking earlier, I think it was Megan, you were asking a great question. So there's so many, watch, we can go. We can go this to this equals this to this. We can go this goes to this, as this goes to this. See, they're all correct. They're all correct. I might go big triangle to little triangle. I mean, there's lots of ways. So if I redraw the big triangle, it's really easy to see, okay? So I'm going to redraw the big triangle on the side. Here's my little triangle. Here's my big triangle. Okay, here's my big one. If I go x plus 5 and x plus 3, right? And let me just concentrate on the little triangle. The little triangle is this one here, right? Okay. So I could go, I'm going to go big triangle to little triangle, big triangle to little triangle, okay? And there's many, many ways to do it, but I'm just going to go x plus 5 goes to 4, right? As x plus 3 goes to 3. So I did big base to little base, big side to little side. Does that make sense? Big base to little base, big side to little side. And again, there's probably about 12 different ways to set this up, but this will work, okay? Cross multiply, right? Cross multiply.
Yeah.
So let's take this times that, and that times that, right? Let's put it down. Let's go 3 times x plus 5 equals 4 times x plus 3, right? 3x plus 15 equals 4x plus 12, right? Minus 3x, I get a 15 equals a 1x plus 12. Minus 12, I get x equals 3. How am I doing? I skipped some steps, but we're in geometry. We know how to solve equations, right? So if x is 3, let's plug it in, right? So let's put a 3 right here. We need BE. Let's put a 3 right here. So I got a 3 plus 5 is 8, and that's my answer. Thumbs up? Okay. All right. Turn the page. Uh-oh. It's a proof. Oh, my goodness. Okay. Well, before we do anything, let's figure out which triangles we're talking about. Okay, triangle EDG. I'm going to EDG. So that's this triangle. We want this triangle to be similar to FBG, to this triangle, okay? So they look similar, don't they? They look the same. They look like the same shape. So how are we going to come up with a plan? So first of all, 1, we got our given, right? You guys know that. 1, we got our given. Now that's a symbol for parallelogram, right? So I've got parallelogram A, B, C, D, and that's my given. So to prove they're parallel, we have to use these three. One of these three things. In fact, this one's not too hard to do because we don't know anything about measures. They don't give us any numbers for the sides, do they? None. So if they don't give us, if there's no numbers for the sides, we're not going to be able to find any ratios, right? So it really narrows it down to just one thing, angle, angle, right? Because we don't know anything about the sides, so it's got to be angle, angle. So let's find two angles. Claire, go ahead.
Vertical angles.
Okay, good. You guys see the vertical angles? Totally agree. So let's go angle DGE. Angle DGE is congruent to angle BGF. Vertical angle theorem. You guys are good at proofs now, aren't you? I know they were kind of a stinker when we started, huh? But now we got it down. Okay, good. Everybody agree with Claire? Katie, what do you see?
Oh, I had it in my head. It was the Z.
It's the Z, totally, because it's a parallelogram, right? So Katie's going to say this, yeah, that angle there is congruent to that angle there. And those are alternate angles. You guys see the Z? So we're gonna, you don't see the Z? Watch. Parallel lines. There's my Z. There's my Z. So angle, step 3, we can say angle EDG. Angle EDG is congruent to angle FBG. And the reason is alternate interior angles. Nice job, Katie. So now, all you need is two angles, right? And we have the two angles. So we can go straight to step 4. What do we have to prove? To prove that. So we can go triangle EDG is similar to triangle FBG. And that's by our angle sim. Don't forget to put the sim, okay? All right, homework is just 474. We got lots of time. You guys got a half hour to get this done. Oodle time, right? Oodles, we got plenty of time. Don't forget to draw the picture, show the work. Draw the picture, show the work, okay? You sure